Very good afternoon to all of you and welcome to the physics live class. So we were discussing about the motion of the elevator. Okay, we were discussing the different aspects of the motion of elevator. What happens in case of the motion of elevator when it is accelerated by A in upward direction, in downward direction, and when A is less than G and when A is greater than G. Let's see that. Let's have a quick recap and we'll continue uh, means then after. Okay, so this is basically your motion of elevator. The first case we have discussed so far, the first case was your lift is moving upward with constant velocity. With
Good one, sir.
velocity. So let's see it. So suppose this is lift. There is a person standing on, okay, and this is lift is moving upward with constant velocity. We have discussed this case. V is equal to constant. So if V is constant, velocity is constant, then acceleration is going to be zero. No acceleration will be there, and the weight of this object will be acting downward, and the reactionary force by the floor of the lift will be acting upward, and this lift is moving upward. So we can write here like this: R minus mg is equal to m into 0. So this will be the case R is equal to mg. This will be the case which is R is equal to mg. In the second case we have discussed so far, what was the second case? Lift is moving upward with acceleration A. With acceleration A. So in this case, we can just understand like this. Suppose this is lift, and the person standing in the lift, and this lift is going in upward direction. A is equal to constant. Okay, this is constant acceleration is there, and this is moving upward. So you can see here the M is going downward. Here the reactionary force, and I told you that the force which is in the direction of acceleration will be taken as a positive, and the force which is in opposite direction of acceleration, that will be taken as a negative. So this will be your R minus mg is equal to m into a, and it will come this side, and it will become R is equal to mg plus ma, or you can say R is equal to mg plus a. So this is the case. This is the case when lift is moving upward, then you will feel your weight become greater than the actual weight. Okay. So in the third case we are discussing, the third case was lift is moving downward with constant acceleration A. With constant acceleration A, and this A is less than G. So in this case, we have discussed so far, suppose this is the case where person is standing in the lift, and the lift is going downward with acceleration A, and you know the mg, weight of this person, is acting downward, and reactionary force is acting in upward direction. So for this case, we can write here mg minus r, because the force in acceleration direction, so this will be positive, and the force which is in against the direction of acceleration will be taken as negative. This will be your A, and this will be r is equal to mg minus ma, and this will be rg minus a. It means what? It means if any object is coming downward with acceleration a, then the weight of that object will be lesser than the actual weight. At that time, the weight will be lesser. Okay, coming to the fourth point. This fourth point was lift is moving downward with acceleration a and a is greater than g. This was the case when a was less than g, and this is the case when a is greater than g. So for this case, we can draw the simple diagram once again. Here, this is the case. mg is vertically downward and reactionary force is vertically upward, and this is moving in downward direction. You can say this a is greater than g. Once again, we'll write the equation here. mg minus r is equal to ma. So this will be your r is equal to mg minus a. Now you can see, and you know the g is lesser, means this g is lesser than a. So r reactionary force will be here negative. So how it can be negative? It can be negative in a case when this person will be not here. This person will be on this surface. If this person will be at this surface, then reactionary force will be in this direction. Then this will be the reactionary force, and this reactionary force will be here the negative. So remember this, whenever lift is coming, this used to come with constant acceleration. Okay, कांस्टेंट एक्सेलरेशन a which is always less than g. अगर ये a g से ज्यादा हुआ तो आप लिफ्ट के फ्लोर पे नहीं रहोगे बच्चे, आप लिफ्ट के छत पे अड़ जाओगे, ऐसे ऊपर जो छत लगी रहेगी. एंड द फिफ्थ केस, when lift falls freely. Freely means what? A is equal to g. Means this is the case when rope of the lift is broken. अगर लिफ्ट की रस्सी टूट जाए बच्चे, तो उस समय क्या होगा? ये लिफ्ट और लिफ्ट की रस्सी टूट गई तो a is equal to g हो गया बच्चे. And this mg is vertically downward and reactionary force is vertically upward. We can write here the mg minus r is equal to m into g. This will be m into a, and a is g, so reactionary force will be 0 at this instant because this object is moving freely. Okay, this reactionary force will be 0. I think it is clear to all of you. Okay, किसी को कोई प्रॉब्लम है? Let me know.
No, sir.
Okay. So coming to the another aspect, that is a question on the basis of this. That is your NCERT question. Question is a rope can stand with 640 Newton. A rope can stand with 640 Newton force. A monkey of mass 20 kg is moving in first case upward with velocity v is equal to 20 meter per second. B is equal to upward with a acceleration. This acceleration is equal to, you can say, the 5 meter per second square, okay, and C moving downward with 10 meter per second square, and D is your moving upward with 20, or you can say the 30 meter per second square acceleration. In which case rope will be broken. किस केस में रस्सी टूट जाएगी? G is equal to, you have to take G की वैल्यू आपको लेना है जो बच्चे 10 मीटर पर सेकेंड स्क्वायर. मतलब ये हुआ बच्चे, क्वेश्चन जरा समझ लीजिए, समझ ध्यान से, कि एक रोप है जो मैक्सिमम टेंशन जो बियर कर सकती है वो 640 न्यूटन, मीन्स मैक्सिमम उसकी जो कैपेसिटी है वो 640 न्यूटन तक बियर करेगी. अगर 640 न्यूटन से ज्यादा टेंशन हुआ तो रोप ब्रेक कर जाएगी. ओके, तो इस क्वेश्चन में पूछा गया किस केस में रस्सी ब्रेक करेगी. तो विल सी इट किस केस में रस्सी ब्रेक करेगी, एंड विल आल्सो ट्राई टू कैलकुलेट द टेंशन इन ईच केसेस. विल आल्सो ट्राई टू कैलकुलेट द टेंशन इन ईच केस. The case in which the tension will be greater than 640 न्यूटन, उस केस में रस्सी टूट जाएगी. और जिस केस में टेंशन will be lesser than 640 न्यूटन, उस केस में रस्सी ब्रेक नहीं करेगी. ओके, हमारा कॉन्सेप्ट समझ रहे बच्चे? ओके, लेट मी नो. Are you getting these things or not?
Yes, sir.
Yes, sir.
Okay, that's good. So let's see कि अगर हम ये चारों केस को हम ड्रॉ करते हैं डायग्राम के थ्रू और आपको समझाने का प्रयास करते हैं. These are the 4 cases. पहला केस हमने ये कह दिया, ये रोप है, ये रोप होगी बच्चे, और इसमें क्या करें, मंकी को अपवर्ड विथ वेलोसिटी, ये मंकी बना देते हैं जरा सा. ये मंकी हो गया, ठीक है, और ये मंकी ऊपर की तरफ जा रहा है, और ये इसकी वेलोसिटी कितनी बच्चे, 20 मीटर पर सेकेंड. बच्चे अब ये देखिए, मंकी का जो वेट होगा वो नीचे की तरफ लगेगा. मंकी के वेट नीचे की तरफ, अगर मंकी के वेट नीचे की तरफ लगेगा बच्चे, तो ये रस्सी में क्या, इस स्ट्रिंग में क्या लगेगा, टेंशन लगेगा ना. टेंशन विल बी एक्टिंग वर्टिकली अपवर्ड, टेंशन लगेगा. अब यहाँ पे देखिए बच्चे, अगर टेंशन अपवर्ड डायरेक्शन में लग रहा है तो आप ये जरा समझिए, यहाँ पे वेलोसिटी कांस्टेंट है, इट मींस एक्सेलरेशन विल बी 0 एंड द टेंशन विल बी योर ओनली mg. This tension will be balanced by the mg, and this is your mass is your 20 and g is your 10, so this will be your 200 newton. So इस केस में रस्सी टूटने का कोई खतरा नहीं है. दिस इज केस 1 है ना बच्चे, केस A यू कैन से. इसमें क्या रस्सी टूटेगी क्या? नहीं टूटेगी.
No, sir.
No, sir.
Coming to the another part, that is B, you can see here. अब यहाँ पे बच्चे फिर से ये जो मंकी है हमारा, ये एक्सेलरेट कर रहा है, और एक्सेलरेशन इज योर 5 मीटर पर सेकेंड स्क्वायर. ओके, और 5 मीटर पर सेकेंड स्क्वायर हो जाएगा बच्चे. तो फिर वंस अगेन विल राइट हियर, दिस इज योर mg एंड दिस इज मूविंग अपवर्ड, और यहाँ ऊपर की तरफ बच्चे टेंशन लगेगा. नाउ विल राइट द इक्वेशन. अब देखिए, ऊपर की तरफ जाने वाले फोर्स को बच्चे पॉजिटिव लेंगे क्योंकि ये एक्सेलरेशन ऊपर की तरफ हो रहा है. अपोज कौन कर रहा है? दिस इज अपोज्ड बाय द mg, दिस विल बी mg इज इक्वल टू ma. सो टेंशन विल बी योर mg plus a, and the mass is your 20 and g is, you can see the g is your 10 and 5 will be your acceleration. So 15 to ja
30.
300 Newton force will be acting here, na?
Yes, sir.
So in when 300 Newton force will be acting on the rope, this rope is not going to break because it can stand with 640 Newton. तो ये अभी नहीं टूटेगा, इस केस में भी ब्रेक नहीं करेगा. लेट्स कम टू द थर्ड केस बच्चे. सो इन केस ऑफ द थर्ड C1, once again this monkey is moving downward. You can see this monkey is moving downward with acceleration 10 meter per second square. So let's draw it. This monkey is moving downward. This acceleration is your 10 meter per second square. Now you can see the mg will be once again acting downward and tension force will be acting upward. We can write equation for it. Mg minus T is equal to Ma, and this tension will be your mg minus Ma.
Zero.
Tension will be your mg minus A. We can put the value here. M is your 20 or G minus A. 10 minus 10 minus 10.
10.
10 minus 10.
0.
Yeah, the tension will be 0 here. There will be no effect on the rope. Okay? There will be no effect on the rope. Coming to the third case, bache.
4.
Fourth case, sorry. In the fourth case, they are saying moving upward with 30 meter per second square. So you can
So
see,
minus 500 Newton.
yeah, this will be your, this is monkey, and this is moving upward. Acceleration is your 30 meter per second square. And once again, the mg will be acting vertically downward and the tension will be in upward direction. So it is moving upward. So we'll write here tension minus mg is equal to ma, and the tension will be your mg plus ma, and the tension will be your mg plus a. You can see here the tension m 20, g is your 30, and acceleration is your 40, 10, 40. So this will be your 800 Newton.
8.
Yes, the tension is 800 Newton and it can stand with only 640 Newton. 640 Newton. It means what? In this case, this rope is going to be broken.
Break.
Okay? तो rope break कर जाएगी कि नहीं बच्चे?
Yes, sir.
सबको क्लियर है ना? कोई डाउट हो तो बताइए.
No, sir.
ओके, तो ना ही हो तो बेहतर है. ओके, अगर हो तो you will be in trouble. Okay, better whenever you feel any doubt, let me know. Okay, and ask me. Okay, coming to the another aspect of this mechanics, coming to that is some common forces in mechanics. Okay, let's have a quick recap on those, and then we'll come to the connected motions. Okay, after the connected motion, I will let you know about the some forces like friction. I will go through the friction. What are the different types of friction? We'll study these and how this friction helps in moving object or means in taking the turns of any vehicle. How these are very useful, and we'll see how we can just differentiate inertial frame of reference and non-inertial frame of reference. Okay, we'll try to understand, and in this way this chapter will be completed. So I hope I will be completing this chapter by the Wednesday. Okay, so if I will get 2 turns tomorrow, and then after one turn, so yeah, hopefully we can complete. Okay, coming to the, that is a common forces in mechanics. Common forces in mechanics. Okay, so we'll see the what are the different common forces in mechanics which are going to act. So the first one is your weight. हमने देखा ना अभी मैकेनिक्स का एक प्रॉब्लम सॉल्व कर रहे थे बच्चे, तो हम लोगों ने देखा ना वेट एक्ट करता है ना, तो वेट क्या होता है बच्चे?
Yes.
इज अ ग्रेविटेशनल फोर्स बाय विच द अर्थ यूज टू पुल एनी ऑब्जेक्ट. ओके, इट इज gravitational gravitational force by which earth pulls the object. This is basically your weight. This is a common force in mechanics. And another is your, you can say, the tension is there, tension in the string. So we have seen here tension in string. If there is any string, okay, so if any object is attached with that spring, then there will be the tension force that will be always acting in upward direction. Or if it is, if a string is in a, you can say, the vertical plane, then the force will be your in upward direction. Otherwise it will be always trying to pull away from the object. Okay, so it will be only possible for the inextensible string. जो रस्सी तनेगी नहीं उसी में ये स्ट्रिंग टेंशन लगेगा. जो रस्सी तन जाएगी बच्चे तो उसमें नहीं लगेगा. ओके, तो टेंशन फोर्स को जरा इसके बारे में ये कह सकते हैं कि द टेंशन फोर्स टी is constant throughout the string. Throughout स्ट्रिंग में आप चाहे जहां पे आप बात करेंगे बच्चे, तो वो टेंशन फोर्स जो रहेगा वो कांस्टेंट रहेगा, वो बदलेगा नहीं. ओके, एंड इट एक्ट्स अवे फ्रॉम एक्सनरी फोर्स. जो उस पे अगर आप एक्सनरी फोर्स लगाएंगे स्ट्रिंग पे तो उससे अवे लगता है. तो ये दोनों तरफ लगता है. अगर स्ट्रिंग की डायरेक्शन चेंज होती तो वो दोनों तरफ लगता है. वो हम लोग अभी देखेंगे भी, एग्जांपल्स में ज्यादा समझ में आएगा. ओके,
Sir, tension can be applied to spring also.
no, there will be the spring force बच्चे. Let me come to there. Okay,
Okay, sir.
spring force. So this is your, another is your spring force. So this is the your spring force. You can say when spring is extended, means what? It means it always pulls the body attached to its end towards it. Okay, or towards you can say towards its center. Okay, in another case, if you are just compressing the string, just a minute. If you are just compressing the spring, then it will be acted always towards, or you can say the away from the center. You can see the example, then we'll define it. Let's say this is your spring. Okay, this is a normal spring, and once you have just stressed this string, you can see now you have extended spring in this way, and the spring force will be acting towards the center. This is the case. And in another case, you can see if this spring is compressed, you can see you have made displacement in this direction, and the spring force is acting in opposite to the displacement, away from the center. Okay, so spring force we can write here when the spring is extended, or you can say stressed, you can say. Okay, it pulls the body attached to its towards its center, while when it is compressed, it pulls the body, or it pushes the body, it pushes the body away from its center, away from its center. Or you can say like this spring force is written F is equal to minus kx, and k is your spring constant, that defines basically the property of the material which is used for making the spring. Okay, so we'll see these things, I mean spring force and all those forces in detail when we'll be solving the question on the basis of these. Okay, coming to the 10 means these are the some common forces which are going to be used throughout the mechanics. Okay, there is one more common force, that is your normal reaction, or you can say the reactionary force, that always acts against the actionary force. Okay, so we are just going to start basically the connected motion. A connected motion, when two objects are connected by the strings and they are placed over the pulley, and we are assuming that the pulley is you can say the frictionless. Okay, so what will happen in that case, let's see it. And one more example you can write here. Okay, I'm not writing, but you should know the fourth one is your reactionary force. Okay, and we have discussed about this, what is basically the reactionary force. Okay, coming to the another aspect, that is your, you can say the connected motion. Connected motion, you can understand in a way, suppose there are two masses m1 and m2 are there, and they are connected by the string and they are placed over a pulley. Let's say there are two masses m1 and m2 attached with a string, attached with inextensible string and placed on frictionless pulley. अगर इसको रख देंगे बच्चे कुछ इस तरह से, लेट्स सी इट, सपोज दिस इज पुली. Okay, and this pulley is attached here, and we have placed like this. Okay, ये दो masses हैं बच्चे, this is your m1 और this is your m2. And now try to understand what I'm trying to say. Suppose m2 is greater than m1. अगर बच्चे m2 greater है m1 से, तो ये m2 will be going upward with acceleration a. अगर m2 नीचे की तरफ जाएगा बच्चे, तो ये m1 भी ऊपर की तरफ जाएगा, and this will be going with same acceleration. क्योंकि स्ट्रिंग को हमने बच्चे इनएक्सटेंसिबल माना है, तो इसका मतलब जिस एक्सेलरेशन से m2 जाएगा उसी एक्सेलरेशन से m1 ऊपर की तरफ जाएगा. Okay, and let's see here the FBD, free body diagram of M1 and M2. If your FBDs are there, FBD, free body diagram for M2, it is M2, and you know well the M2G means weight of this will be acting downward, and this is your reactionary force. There will be the reactionary force, and this is moving downward with constant acceleration a. And for m1 you can write here reactionary force, you can't write reactionary here, but here will be the tension force.
Yes, sir, tension
Force which is acting in the string. So this is moving downward a, and now we can make similarly for the m1. Now this m1 will be here, the m1g will be acting downward, and the tension will be acting vertically upward. And you can make here also, this is the tension. This is the tension basically. Here the tension will be same throughout the string. Tension बदलेगा नहीं कहीं पे भी. आप अगर देखिए ये M2 के लिए बनाया मैंने, ये M1 के लिए बनाया. नाउ वी कैन राइट हियर द इक्वेशंस. ओके, फॉर M2 के लिए लिखेंगे बच्चे, ये तो नीचे की तरफ जा रहा है, ये ऊपर की तरफ जा रहा है. M2 के लिए लिखेंगे बच्चे, देखिए ये नीचे की तरफ जा रहा है, तो वी कैन राइट हियर M2G, एंड इसको अपोज कौन कर रहा है बच्चे, टेंशन. सो माइनस T इज इक्वल टू M2 into A. This is our first
M2.
equation. And in the first case, for M1 we can write here, for M1 we can write, this is moving upward, so we'll take tension as a positive. So this will be E minus M1G is equal to M1 into A. This is our second equation. We can just add these two equations, adding first and second. We can add these two equations. We can see the tension is going to cancel out. This M2G minus M1G is equal to M1A plus M2A, and the A from here will be your M2 minus M1 upon M1 plus M2 into G. This will be your acceleration. This will be the acceleration of the body. Now, using the acceleration, we can find out the tension in the string by putting this, the value of acceleration, in the equation first or second. पहले इक्वेशन में या दूसरे इक्वेशन में बच्चे एक ही वैल्यू रख देंगे, then we can get the value of tension here. Okay, let's see here how we can determine. Okay, I'm changing the color here. Putting value of A in equation 3 or in equation 1. So this will be your M2G minus T, and acceleration M2 into A, and the A is nothing, it's your M2 minus M1 upon M1 plus M2 into G. Solve it by how we can solve. We can we can do by transferring this to this side and tension, keeping tension at this side only, or we can just transfer this to this side and we can make we can do the tension at this side. So tension will become, this will become, what will be this? This will be your, you can see here, the M2G minus of M2, and this will be your M2 minus M1 upon M1 plus M2 into G. This is the case, and we can solve it. How we can solve it? We can get here, you can see, we can just multiply here and it will be your, what will be this? This will be your M1 M2 G, and this will be your M2 square G, and this will be your M2 square G, and this will be your plus of M1 M2 G, or upon this will be your M1 plus M2. From here we can just cancel out, we can add, and the tension will be your, this tension will be your twice of M1 into M2 upon M1 plus M2 into G. This will be the tension acting in the string from both the side. यहाँ पे ये जो टेंशन होगा बच्चे, दिस विल बी द फॉर्मूला, चाहे आप यहाँ का टेंशन निकालें चाहे यहाँ का टेंशन निकालें. So in this way you can solve the question based on the connected motion. Okay, we'll do certain more question on the basis of this because it's very interesting, you know, and we'll see if थोड़ा सा और interesting देखेंगे कि अगर इस पूरे सिस्टम को एक एक्सेलरेशन से ऊपर नीचे करने लगे तो क्या होगा. Okay, so we'll see that things, but for today this is for today, and we'll connecting tomorrow, and then we'll discuss further. Okay, is there any doubt?
No, sir.
Okay,
Bye, sir.
tomorrow and then we'll discuss. That's it for today. Thank you.
Bye, sir.